Page 173.
For the second part, on 173,
Yeah?
should we turn the percents into decimals?
It's up to you. It's not vital to have it one way or the other.
Okay.
So it can be the same on the
Okay, yeah, hang on. Let me just make sure. Okay. Well, let's work one. So you're saying like turn 8% into 0.08?
Yeah.
Yeah.
Okay. So up above it says you have 10%. They already know this. And then they say, you know, hey, you have a score of 8%. If you leave them both as percents, it's going to come out right. If you turn them both into decimals, it'll also come out right. So it becomes your choice. Just don't have one kept as a percent and convert the other to a decimal. Either keep them both as percents or both as decimals. I would say in this case, keep them as percents so you don't have to deal with a decimal. Does that make sense? All right, so let's see. Problem number one, Jim Carrey is 74 inches tall. What is his Z score? So 74 minus 69 over the standard deviation 2.5, so Z of 2. Shaquille O'Neal's 85 inches tall. What is his Z score? So doing that, looks like his Z score, he's 6.4, so he's 6.4 standard deviations to the right. And this director is 63 inches tall, so we find the Z score, which is negative 2.4 as a Z score. And then they gave you a Z score of 4.4, so you work backwards, plug in 4.4 in for Z, work backwards and do the algebra, so you get 80, and number 5 is 62 inches. Any questions on how to do 1, 2, 3, 4, or 5, or was it relatively simple algebra? Cool. And then 6, you're just drawing a Z-score table, linear. So you have negative 3, negative 2, negative 1, 0, 1, 2, 3. 7, you get a Z-score of negative 0.5. 8, you get an answer of 1.25. 9, you get an answer of 10%, or 0.10 if you converted that. In what year, or where you had a Z-score of negative 4.5. So you go and you do the math. What was the investment return? Oh, what'd you get there? That was number 10. So number 10, they tell us we have negative 4.5 is our Z-score. We're trying to figure out X minus 10 over 4. Multiply both sides by 4. So that's going to give me negative 16, let's see, 4, 2, 16, 18.0. X minus 10. So X equals negative 8. I believe I did that right. And then, like say, explain what a positive Z-score represents in the context of this question. Something like an investment return that is above average is a positive Z-score. And then 12, let's make sure you have the same 12 as me. Some do is fishing. So if you're a fisherman, you might catch your interest. Someone had a Z-score of 1.2. So what does that mean? That means that this fish that was caught was 1.2 standard deviations above the average. James Fisher standard deviations, or he was 3 standard deviations below the mean. So if you had a Z-score that's negative 3, you're 3 standard deviations below. Fisherman contests at Chatfield Reservoir, you have that. Which is the larger type? A 6-pound largemouth bass or a 7-pound walleye. So the largemouth bass would be 0.417 as a Z-score, and the walleye would be 0.533. So the walleye is more standard deviations to the right. And then which is larger relative for its size, a 4-pound rainbow trout or a 5-pound walleye? And if you go and do that, you're coming out with a rainbow trout. And then A friend takes a test to obtain a z-score of 0. Your friend says, I got a 0. That's awful. You explain that it's not so bad. So if you get a z-score of 0, that means that you are at the average. Okay, so what they are continuing to do.
Know this answer real quick? Why, when I see live proctoring, I've got 6 people that don't show up. 5 out of 6 of them are middle schoolers.
That's probably why. So were they able to submit it?
Yeah.
Okay.
Should I just write you the name?
Yeah, write me the names and we can do a search and verify.
Okay. So I'm just keeping track of who we need to figure out.
Cool. So this is normally going to be 0. And then if we go +1, +2, +3, those are the standard deviations to the right, to the left. Okay. Now, this is just general. If we have, an actual mean that's given, and if you knew the standard deviation was, say, 5, you could say that these are then 60, 65, 70, and you could have 50, 45, and 40. So those are just a few things that are available in that situation. Okay, do you feel okay with 3-1? Does it seem to make sense? Is there questions about, we haven't gotten into the actual normal curve. We're just talking about z-scores, so we're just talking about above and below the averages for right now. Okay? But now we are on page 67. And on page 67, it says, what is a normal distribution? Okay. So I need to give you a heads up. We have not seen the equation yet of how to find the standard deviation of something. Does that make sense? But we will find, actually, I think Desmos will actually do it for us. But so when we are going and taking a look at this, it says a normal distribution is something you want it based on a bell curve. A bell curve is also referred to as a normal curve. Okay, now, right now, when you get data, that's raw data, if you go and just try and plot raw data, you have as far as test scores, it probably won't come out to look like a normal curve. So what you have to do is you have to make it so it will fit as a normal curve, meaning you would have to find the mean. And at some point, let me see if it's in today's. I can't remember if it is. No, it's not in today. So, but the normal curve can be generated once you find the mean, and then once you learn how to find the standard deviation. And again, your calculator or your phones will do it. Okay? So a normal distribution is a distribution of data which most of the results are occurring near the center at the mean, and they taper off symmetrically. Okay, so a good normal curve basically should look like this. So if I am in the world of math, if we are one standard deviation and we wanted to know what that point was here or what the point was here, if we were to take a straight line and draw it in a way so it's kind of kisses it once, that's a bad normal curve. Undo, undo, undo. If you had something like this, then the slope over here, though one would be a positive slope, one would be a negative slope, they would still have the same amount of rise compared to the or amount of fall. Okay, so it's symmetric about itself. Whereas if you found the mean, the slope of the mean is just going to be 0. It's a horizontal line. But a normal curve, when drawn appropriately, you're going to look at it like this. The entire area, the area underneath the entire curve, will be 100% of the area. Does that make sense? Okay, so when I say area, I'm talking literally length times width. Okay, so what you're really thinking about happening here is if you had a whole bunch of rectangles in here, and if you've ever taken calculus or pre-calculus, if you've ever heard a term called Riemann sums, means that you're summing up these rectangles, and if you add up all the areas of those rectangles, they're going to count for 100% of our area. Okay, and these rectangles can exist on both sides, or do exist on both sides. Okay, and there's other things in calculus that are called the trapezoidal rule, things like that, and it's just making the different shapes underneath. And the thing about the area underneath it, each one of those rectangles should have the same width. They're going to have different heights. Okay, in order to find the area of a rectangle, it's length times width. If I were to take all those length and widths and sum them up or add them up, I would get to 100%. On this side of the mean, you would have 50% of your data, and on this side of the mean, you'd have 50% of the data. Okay, if I have one standard deviation, so the pink we'll call a standard deviation, within that first standard deviation, you're talking about 68% of your data will fall there. So when they say most of our data will occur near the center, then it's near the center, it's within one standard deviation. So 68% is more than half. Okay. The purpose of this section is to analyze the data to see if we have normal distribution is a reasonable model for the data, the set of data. For example, the medical student doing a thesis about cholesterol levels will need to collect cholesterol levels from a large sample of people. Checking to see if the cholesterol levels are normally distributed may be a part of the process. Are cholesterol levels normally distributed, or would it be skewed right or skewed left? So there's a term where, remember, skew left. This is skew left, and this would be skew right. That would be, is it right or left leaning, or is it normal? Okay, skew right or skew left, you could still use them theoretically, but we're going to stay away from it. We have a problem. Usually we can't obtain every possible value of data set. We can make various data sets using our collected data, but here we must acknowledge that our data display can only be an estimate of true distribution. In other words, we're using our sample and hoping that it is representative of all data collected. One method for investigating a data set for normality, meaning it's going to create a normal curve, is to make a histogram or dot plot or stem plot or box plot and visually check for normality. This is a pretty informal method. It can be used, it can be problematic with a small sample size, and is dependent upon the scale we use. So when we talk about the scale, we're talking about in the X direction. How narrow were my rectangles? Okay, so if you had say collected data and you made a histogram based on it, that would be only 3 pieces of data that we're trying to fit into a normal curve. Okay, the more and more those rectangles become closer and closer and closer together, smaller and smaller widthwise, and the more pieces of data, the more it should be able to fit into a normal curve if it is a normal curve. Okay, so on page 68, if you check the histogram bars closely, you can see that the symmetry isn't perfect. That's okay. Perfect symmetry in data is not a reasonable expectation. However, the overall shape certainly will take the classic bell curve, take on the classic bell curve closely. The data set is approximately normal, which is good enough for most statistical purposes. Using a box plot to check normality is tricky. The following diagrams show what normal distribution set should look like when the box plot is used. Okay, so they have a box and whiskers graph. Box and whiskers does not deal with mean and median, or it deals with median and quartiles. So Q3 and Q1. And then normal distribution would deal with the mean. Okay, so there are ways that you can sit there and say, if my box and whiskers graph is symmetric and the boxes are the same size and my pulling right and left are the same, that's one test to see, do we have some sort of normal distribution? If that is true, then great. So normal distribution has a bell curve feel, but symmetry is imperfect. Sometimes it comes down to a judgment call, whether it's normal or supported. Judgment calls make some people uncomfortable, which led to another, more advanced techniques for checking a data for normality. Most of those won't be part of this course. Okay, so in this next session, we'll discuss more of that. So let me talk about a very normally distributed test. ACT. Well, somebody use your phone, look up for me, and find me what the average ACT score is in the United States. $19.8. Did it tell you the standard deviation? Or maybe type in, what is the standard deviation of the ACT?
5.
5. All right. So just for simpler purposes, let's just round 19.8 to 20. Is that okay? All right. So we're just going to round this to 20 just to make this look a little nicer for us. So if we were to put this as a normal curve, we would say that this is 20, this is 25, this is 30, and this is 35. And then you have 15, 10, and 5. So what we can do is this one standard deviation range will account for 68% of all of our scores. Okay? So 68% of the scores on the ACT, if we rounded the average to 20 and the standard deviation was 5 that was given, 68% of the people that take the ACT will score between a 15 and a 25. Okay? So that means that 34%, half of 68, 34% will fall between a 20 and a 25, and 34% will fall between a 15 and a 20. Okay? If we went a little bit further, you're going to get a larger amount of people that would fall between a 10 and a 30, and a larger amount that would fall between a 5 and a 35. Okay? The amount that falls between 5 and 35 is not 100% because we can actually go further. What's the highest score on the ACT? 36. So highest score is a 36. So think about where a 36 would fall. So that 36 falls more than 3 standard deviations above the average. How likely is it that we get, well, let's ask this. How likely would it be that everyone in this class would score a 36 on the ACT? Yeah, it's pretty, we have a better chance of getting struck by lightning twice, right? And it's not because we're dumb, okay? and it always baffles me that, you know, I know that there's tutoring centers and all these kind of things, and you'll see on some of these tutoring signs, guaranteed 2 points higher on the ACT with our tutoring services. That is what they're guaranteeing, right? You know, it's a sales pitch, right? So yeah, I'm gonna go drop, you know, $50 to $100 an hour, sit with this tutor who's gonna go over an ACT test with us over and over and over and over again. And then so when we sit down and take it, hopefully we would get two more points higher than what we normally would have had. Now, Creek a couple of years ago had like 23 students at Creek that got a 36. Okay, that's pretty good. Like there's not a whole lot of other schools that really can state that number. So any given year at Creek, you're going to have roughly 1,000 students of that particular class that would take the ACT. So we had 23 perfects out of 1,000, which is 2.3 out of 100, which is 0.023%. Okay, is 0.023% good? No, not really. Actually, I take it back. I just did my math wrong. That's 0.023. If I made that a percent, it becomes 2.3%. So 2.3% of our students, if we had 1,000 in the class that took it, that scored that. So think about this. 68 fall here. Now there's a little precursor. You're going to get within 2 standard deviations, you're going to get 95% of your population. Within 3 standard deviations, you're going to get like 99.7%. So that means if you go further out, you're going to get, if you go to 4 standard deviations, I believe it goes to 99.9. If you go to 5 standard deviations, it's like 99.99. Okay, so the area is getting smaller and smaller and smaller. So this versus where this falls is pretty incredible. Okay. Did that happen because we just happen to have a higher amount of really good test takers that year? I don't know. Was it because the learning and the teaching was so much better? I don't know. I mean, we'll hang our hat on it saying, man, look at how well we did and ta-da and la-ti-da. But when it comes down to it, it's just an anomaly that took place, which congratulations to those students. But, you know, what should we always hope that's happening every year? If it did, something really is good in the water in this area. All right. So I'd like you to work on, let's see, check this data set below for normality. Okay. So I'm on page 175. So if you turn to that, I want to show you how problem number 1 can be done on Desmos. All right. All right. Desmos, here we come. So, what do you want to see? 1, 2, or 3? You want to learn about goals scored each game for a soccer season, lifespan of golden retrievers, or time it takes for people to complete an online crossword puzzle? 3? Okay. Laura, you have it open to number 3?
Yeah.
Okay. Can you hang? Don't say it yet, but will you, when I prompt you to, read me going across. Go ahead.
32,
Gotcha.
41,
Gotcha.
37,
37,
19,
19,
51,
51,
44,
44,
39,
39,
61,
61,
45,
45,
30,
30,
42,
42,
24,
24.
Yeah.
Okay.
52,
52,
36,
36,
39,
39,
46,
46,
29,
29,
50,
50,
44,
44,
39,
and what?
39.
39. Thank you. All right. So if we wanted to just look at what these things is, it should be just dots. Nope, they're not even going to show up. Okay, because I didn't have a Y value. All right. So then from there, let's see. I can do. I got to remember how to do this. Nope. Done. I can go stat. Nope, that's not what I wanted. I have to look for it. Go under functions, statistics. We can find the mean of x1, which is 40. We can do the functions, statistics, standard deviation of x1, and standard deviation is rounded to 10. Okay, so you have time it takes people to do a crossword puzzle. So the average is 40 minutes. 68% of the people would get it done between 30 and 50 minutes if I added or subtracted 10 from 40. Okay, so it says check each data below for normality, creating a display a histogram, dot plot, or stem plot. Okay, so let's do a histogram of x1. And that's basically what our histogram is. Okay, the histogram might look good. We might want to say box plot of x1. And so let's turn this one off. Let's turn that off. So the box plot, it appears it is relatively normal. Okay, based on our data. Okay, if we're looking at the box plot, our median is 40. We said our mean was 40. That's good. You know, it's symmetric about it right now as it sits. The histogram, I've turned it back on. We might be able to change our width. Set width. Oops. Of 1. Let's go 5. So those are a few things. So 175, 176. Take care of it. Have a great day.